Now this problem in the year 2025, this is a very beautiful problem. So let's try to solve it. Consider the first 100 natural numbers. First 100 natural numbers means 1 to 100. The numbers, natural numbers, are basically the numbers which we use for counting. That just starts with 1 and it goes like 2, 3, 4 till 100. How many of them are not divisible by any one of the following? So it should not be divisible by 2, 3, 5, 7 and 9. Now there are many ways to solve it, and one way is very efficient, but of course in the examination hall that is not going to work. So first method I'm going to show you is the easiest way to solve this problem, even though when you have no idea how to solve this problem. And after that I'm going to show you the most easiest method. So in this method, if you look at this, the number 3 and 9 have been given. See, that's actually a repetition. That basically means every number which is divisible by 3, that will automatically will be divisible by 9. So we don't have to check the divisibility of 9. We only have to check the divisibility, or if it is not divisible by 2, 3, 5 and 7. We only need to check this, number 1. Now, the easiest way how to solve this problem without using any brain, just solving, is just see. If we are looking for numbers which should not be divisible by 2, if a number is not divisible by 2, that basically means that should be odd numbers. So 1, 2 should not be there, 3, 5, 7, 9, 11, 13, 15, 17, 19, and it keeps on going, and the last session will be 91, 93, 95, 97 and 99. This many numbers. Now this number is also not divisible by the number 5. That automatically eliminates everything which is ending with 5. The number will not end with 0 because that's automatically eliminated because it is divisible by 2. Now again, if we look, there are 2 more numbers which we have to see, 3 and 7. Now if you look, the numbers which are divisible by 3, this should not come, this should not come, 17, 19, nothing over there. And you can keep checking. Actually, this number is divisible by 7, and it keeps on going. Now if you solve till now, then you will observe something, and that is, see, there are lots of numbers which are in between also which you have to check. But if you observe till now, okay, not divisible by any one of these numbers. Of course 7 should not be there, 5 is anyway eliminated, and so on. The one thing which you will see is that in this column you will see a pattern. The pattern is 11, 13, 17, 19. They are not strangers, they are prime numbers. In fact, even this is eliminated because it's divisible by 9 and 3. 93. What about 93? It's there. Is it divisible by? Yeah, it's divisible by 3. It's eliminated. Even 97 is a prime number. Now, once you observe this thing, then you will find that you're basically looking for all the prime numbers which are greater than 9, or the prime numbers which are from 11 till 99, or we are looking for the prime numbers from here to here. That is the number which you are basically looking. So you have to know the prime numbers which are from 1 to 100. And again, for remembering that, I do have a method. I call it the Pulu's method because Pulu developed it. So we have to learn that thing also. So we are going to see what Pulu's primes are. So how this method works is that, first of all, you have to assume that we have the numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like that we have written till 100. You have to assume that thing. Out of this thing, you see, the first column, that is first column and second column, 1 to 20. These many numbers, the prime numbers from in this category you have to by heart. There is no other way. And because that's a prime number which you are going to use actively, it should be available in your random access memory. So let's learn that thing first. Our first prime number is 2, second is 3, then we have 5, then we have 7 in the first row, in the first column. Second column we will be having 11, 13, 17, 19. You have to by heart this. There is no other way. Okay, now is the actual place where Pullo's primes method is getting implemented. The first step is that all the prime numbers, the edges, that means here we will have 1 will not come, here we will have 10, that will not come, we will have 91 in the edge, that will not come, we will have 100 in the edge, that will not come. That's the first method. First rule is that the edges should be eliminated. Eliminate edge. Now we will go for second method, that is the reference point. See, whenever you have to find or go somewhere, you actually need a landmark. Just like this, we also need a landmark or a reference point. We are actually taking the help of three reference points. First one is 30, second one is 60, and last one is 90. These are themselves not prime numbers because all of them are divisible by 5, 10, etc. But they are the reference point. Now, from each reference point, we can come to the next prime numbers. Just before 30, we will have 29. Just before 60, we will have 59. Just before 90, we will have 89. They are prime numbers. And again, from 29, we have to take a leap, a number which is ending with 3. From 29, if I take a leap, the number ending with 3 is 23. From 59, if I take a leap, and the number ending with 3 is 53. From 89, if I take a leap, the number ending with 3 is 83. They are also prime numbers. Again, go back to our reference point. The number just after 30, we have 31. It's a prime number. Number after 60, 61. It's a prime number. Number after 90, of course, 91 is not a prime number. It's already striking the first rule. Now, come back to this 31. Number ending with 7 after 31. You take a leap from 31, you will find. Take a leap from 31, you will find the number 37. It's a prime number. Number after 60, take a jump, you will find 67 is a prime number. Number after 91, okay, take a leap, you will find 97. They are also prime numbers. Now there are two columns which we actively skipped, the one starting with 41 and the one starting with 71. In these two columns, it's a special column. We have three prime numbers each. The first guys for 71 and 41 are prime number. In 40, if we go the next odd number, 43 is a prime number. And if we go forward, the next odd number, of course, it is 45. That is anyway divisible by 5. It is not. But then we have 47, the year when we got independence. That's again prime number. We got 3. In 70s, 71 is a prime number. And the very next prime number is the next odd number, 73. The year when Sachin Tendulkar was born. Or the year when Keshavananda Bharati case happened. Or the RTO registration plate of Sultan Bathery. That is a prime number. And if you check the next odd numbers, see, even numbers anyway cannot be prime number. We'll see more about that in the session of prime number. If you move forward, 75 is not a prime number. 77 is also not a prime number. It is divisible by 7 and 11. But we need 3. So that is 79. Okay. So the third rule is the rule of 40s and 70s. We have 3 primes each. So I'm going to repeat this thing once more. It's actually easy. You just need to practice like maybe 2-3 times. So let's do it once more. So we are going for Pullo's primes. Okay. First rule is the edges will not come. 1 is not there. 10 is not there. 2, 3, 4, 5, 6, 7, 8, 9. 91 is not there. And then 100 is also not there. Now we have to write down all the prime numbers in the first 2 columns. That you have to by heart. Okay, there is no other way. We have 2, 3, 5. Let's space it properly. 7. Okay, 2, 3, 5, 7. Let me put this thing. 10 is not there. 100 is also not there. And similarly, we also have 11, 13, 17, 19. These 8 prime numbers you have to by heart. Now if we move forward, we'll go for our reference point. that is 30, which is not a prime number. Cross it then itself. 30, 40, 50, 60 and 90. Okay, before 30 we will have 29, and take a leap, we will have 23. After 30 we will have 31, take a leap, 37. Before 60 we have 59, take a leap, we will have 53. After 60 we will have 61, take a leap, and that is 67. Before 90 we have 89, take a leap, we have 83. After 90 we don't have 91, we just have to take a leap, 97. Okay, and then we have the columns of 40 cent, 40 cent, the other thing was 70s. In that we have 41, 43 and independence 47. And then we also have the column of 70s. In the column of 70s, we of course have the first one, 71. We also have 73. Then 75 is not there, 7 is not there, we have 79. So now you can see there are 25 prime numbers. Okay, how can we see there are 25 prime numbers? In the first column we have 4, next column we have 4, here we have 2, here we have 2, here we have 3, here we have 2, here we have 2, here we have 3, here we have 2, and last one. If you add all of them, 4 plus 4, 8, 10, 5, 5, 10, 10 and 22, 24, and last column 1, 25 prime numbers are there. Okay, now according to our question, we are looking for we are basically looking for all the prime numbers from here till here. From 1 to 100 we know there are 25 prime numbers. Out of them we have to eliminate the 3, 5, 7 and 9, because they are also prime numbers, they are actually counted in this 25. So we have to minus 4. So we will find the answer is 21. But don't stop there, because 1 is also there. 1 is neither prime, it is not what's other thing, composite. So even 1 is not divisible by 2, 3, 5 and 7 and 9. So that also should be added. So 21 plus 1, that is 22. So answer for this problem is 22. Now this is the easy method. Okay, now there is one more theoretical way to approach this problem. If you look at this thing, see how to actually determine if a number is prime or not. For example, if I want to see, let's take the number 100. I want to check if this is prime or not. Of course, you know it is not prime because it is divisible by 10 and 5 and 2 and so 4, etc. But if I want to actually check if this number is prime, what I will do is that I'll take the square root of this number. If I take the square root, I'll get 10. Then I just have to see all the prime numbers till 10. That means 2, 3, 5 and 7. So I have 2, 3, 5, 7. Now I have to check if this 100 is divisible by any of this number, 2 or 3 or 5 or 7. If it is divisible by any one of this number, then it will not be prime. Let's take one more example. If I have the number 101. See, of course, I don't know how to take the square root of this thing. It's totally fine. You just have to find a perfect square which is just above this thing. We have 121. If you take the square root of 121, you are going to get 11. So 121 is just above 101 and it's a perfect square, and the square root of 121 is 11. So I have to list down all the prime numbers till 11. That means 2, 3, 5. This is enough, but let's take 11 also. Now check if this number is divisible by 101 is divisible by 2. If you check, the last number is what? Not divisible by 2. Adding 1 plus 0 plus 1, you are getting a number which is not divisible by 2. So divisible by 3, it is not divisible by 5. Sorry, 3. The last number is not 5 or 0, it is not divisible by 5. Now divisibility of 7, we'll see the divisibility rules also later. It's not divisible by 7. Divisibility rule of 11. 2 minus 0, it is not divisible by 11. See, 101 is not divisible by any of this given number. Therefore, this will become a prime number. So that is a rule. Okay. Now the question is basically asking you to check uh, the number of natural numbers which are between 1 and 100, okay, which are divisible by 2, 3, 5, 7 and 9. First of all, here itself I can eliminate the number 9, because if a number is divisible by 3, it is automatically divisible by 9. Now if I check, see, 1 to 100, all the numbers still 100. Okay, if we want to check, the highest number itself is 100. We just saw, to check if 100 is a prime number, all you have to do is take the square root of 100 and you'll get 10. All the prime numbers still 10 are 2, 3, 5, 7. If any of the number from 1 to 100 is not divisible by 2 and 3 and 5 and 7, if any number till 100 which is not divisible by 2 and 3 and 5 and 7, that automatically makes them prime numbers. So we are basically looking for the prime numbers. But then the added condition is that, see, so the first thing which we understand from here is that for all the natural numbers till 100 which are not divisible by 2, 3, 5 and 7 are basically the prime numbers till 100. But from them we also have to eliminate 2, 3, 5 and 7, because 2 is divisible by 2, 3 is divisible by 3. So out of 25 prime numbers you have to remove these 4 numbers. Then you will get 21 numbers. Then into that you also have to add 1, because 1 is not divisible by, it's a smaller number, it's not divisible by any of this number. Therefore you will get answer is 22. So if you understood this concept, you could directly solve this problem. Okay, I'll give you one practice question. So this is a prerequisite which you need to solve the next problem. So that is, from the natural numbers from 1 to 100, there are 25 prime numbers. From 1 to 500 there are 95 prime numbers, and from to 1 to 1000 there are 168 prime numbers. Okay, so just note it down somewhere. You'll need this for the next problem. Now I'll give you the problem. In the first 1000 natural numbers, find the number of numbers not divisible by 2, 3, 5, 7, 11, 13, 15, 17, 19, 21, 23, 29 and 31. Okay, so you can pause the video and try to find the answer. Even I have not found the answer, I just made the question. So we'll do it together. You just try to find the answer yourself. Okay, I'm going to give you the solution. So one thing which I know is that from in the first 1000 natural number I have 168 prime numbers, and we are looking for the numbers which are not divisible by these many numbers. If you look at this number 15, I can eliminate, because anyway 3, if it is not divisible by 3 and 5, it will not be divisible by 15. 21 also I can eliminate, because 3 and 7 is already there. Now these numbers are basically the prime numbers from 1 to 31, because you know the first 8 prime numbers, 2, 3, 5, 7, 11, 13, 17, 19, they are given. On top of that, our reference point 30. Before that we have 29 and 23. After that we have 31. So they are basically the prime numbers. So a number we are basically looking for. Okay, we are basically looking for. Let's see. We have 1000 over here. I don't know the square root of 1000, but let me take. You know, if I take the square root of this thing, I'm going to get 100 into 10. Square root of 100 into 10, or this will come out 10 into root 10. Root 10 value you should actually learn, because it will come. It's similar to pi, but it is different. It is 31.6 something. Okay. Anyway, this is gonna be 31 nahi. That is 3.16 something. So it is gonna be 31.6. Now I can just round it to, let's say, 31. So basically I'm looking for, I just want to see if, even if I want to see if 1000 is a prime number, I have to just write down the prime numbers from 2 to 31 and check if any one of them can divide 1000. Of course 1000 is divisible, but all the numbers till 1000 also follow this thing. If it is not divisible by any of these given number, any of these prime numbers, that basically mean that they themselves are prime numbers. So we are basically looking for the prime number. So there are 168 prime numbers. Out of them we have to eliminate these many numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have to eliminate these 11 numbers, because If I take 11, 11 will automatically become divisible by 11. So if I eliminate these numbers, I will find 157 numbers. 157 numbers will be there which are not divisible by them. But again, we also have to add the number 1, because 1 is anyway not divisible by any of them. So if I add 1, you will find there are 158 numbers which satisfy these conditions, and that's answer for our problem. So that's it, guys. Thank you. So anyway, the answer for this problem is 22.